So good morning everyone. So today we discuss about speed control of induction motor. So last class we discussed about starting methods of induction motor. The speed of the induction motor ns equal to 120 f by p. What is the speed of the motor? Actual speed. The actual speed n equal to what? ns into 1 minus s. ns into 1 minus s. What is the PC? Rotor copper loss. Rotor copper loss PC equal to sp2. What is the s? PC by p2. That is rotor copper loss divided by rotor input. So from this above equation, this above equations, the speed of the motor can be changed either changing its synchronous speed or by changing the slip. That means the change in the synchronous speed by changing the slip can be controlled. So in this, two types of speed control is there. So one is from stator side, another is from rotor side. So from stator side, first one is by changing the supply voltage. So by changing the supply voltage, the speed of the motor can be changed. Because of the changing the supply voltage, changing the torque, changing the speed, by changing the supply frequency. From that ns equal to 120 f by p, if we change the frequency, the speed of the machine can be changed. That is also from stator side. Another is number of poles. So that is by changing the number of poles. If the poles of the machine increase or decrease, it's inversely affect the speed of the machine. These three methods are from stator side. So next, rotor side. From the rotor side. So by changing the rotor circuit resistance. By changing the rotor circuit resistance. This is the one method. The resistance have to be changed, the torque of the machine is changed, the speed of the machine also changed by injecting the voltage. Into the rotor circuit. So last one is by cascade control. In these two motors can be controlled and the poles of the machines can be changed. That is the cascade control method. So these are the methods from stator side and rotor side. So stator side I can see the by changing the supply voltage. Changing the supply voltage by changing the supply voltage. So the torque developed in the induction motor can be torque equal to, what is the torque? SC2 square R2 divided by R2 square plus SX2 square. This is the torque, that is the full load torque. This one is full load torque. What is the starting torque? The slip is 1. Slip equal to 1. Substitute E2 square R2 divided by R2 square plus X2 square. R2 square plus X2 square. So that means, so the torque is directly proportional to slip times V2 square. The torque is directly proportional to slip times V2 square. If the supply voltage is reduced below rated value, the supply voltage is reduced to below rated value, the torque also decrease. The torque also decrease. That means if the voltage is decreased the below rated value, the torque also decrease. To produce the same torque for supplying the same load, to produce the same torque for supplying the same load, slip is increases. Slip is increases. So motor running at low speed to decrease the supply voltage. If in case motor running the low speed, to decrease the supply voltage. Decrease the supply voltage. The maximum torque developed in the maximum torque developed in reduce considerably reducing light speed. Reduction in speed. The torque characteristics for the reduced supply voltage is like that. I am taking y-axis torque and x-axis speed from actual speed n equal to 0 to n equal to ns. So this is the characteristics. This is like that. This is with normal voltage. If the voltage is reduced, the torque is reduced, the speed of the motor also reduced, the maximum torque also reduced. This is like that. This is with reduced voltage. This method is, this one is torque speed curves. This method is very simple and cheapest method. It is rarely used because large change in voltage is required for small change in speed. So that means this method of this very simple and cheapest but rarely used, because for small change in speed we require large voltage change. large voltage change. This method is suitable for small motors like driving fans whose torque is proportional to square of the speed. Whose torque is proportional to square of the speed. This is of the one of the method, that is by changing the supply frequency and number of poles. From this one, stator side is completed. So this is the speed control techniques and steps from stator side, rotor side. So today we discuss about speed control by changing the supply voltage. So thank you everyone. If you have any doubts, please respond in our group.